So in the last lecture, I started with finite automata, its machine model of finite automata, and during discussing the finite automata, we came across the language a raised to n, b raised to n, which we identified that this is the language which cannot be accepted by a finite automata. Okay? And to accept a finite automata, we were looking for an alternative machine. And that machine we really gone for. We designed that machine, and during designing that machine we came to know that the designing machine should have a additional memory with it. Okay? So that memory we added, that we can term as a stack, we added to that finite automata, and the finite automata with memory, and that is stack in the form of stack, can be very clearly called as pushdown automata. Please note down this. Pushdown automata is nothing more than a pure finite automata with memory. That is called as a pushdown automata. So, do you remember that we really did some comparison study? First of all, I prepared a machine model for a finite automata, and then we really gone for getting a finite automata to accept this particular language. And I was clearly, we all were very much convinced with the fact that it is impossible to have a finite automata to accept this language, because in this language it is very much necessary to keep track of number of A's you produced before producing the number of B's. Okay, so that number of A's, that count is not at all our finite automata was able to record. Finite automata record नहीं कर पाता. Finite automata was blindly producing the A's or B's, okay, but it was unable to count the number of A's, because see, here we are needed. This is the language. These are the kind of string which having same number of n number of A's followed by n number of B's. So this number of A's and number of B's should be equal. So when you are going for producing B's after producing A's, then you must be known to the information that how much number of B's I should produce. That number is important to come up with this language, this kind of sentences. Our finite automata was not able to do that. That's why we move towards a new machine, or what we did exactly to the finite automata, we just added a memory, and that memory was having a behavior of particular kind, that is a stack, first in, last in, first out. That is why stack memory we added to the finite automata, and such finite automata you can term as a pushdown automata. Okay, the difference between the working of finite automata, I will clearly show you what exactly is the difference between the working of finite automata and working of pushdown automata. Finite automata is most importantly the working behavior of finite automata is like this. Finite automata is a machine. To the machine, we really inputting the string, and our machine is really processing that string. But we are interested in how really finite automata process that input stream, and that processing was like this, by having, or you can say being in a particular state and having input symbol at that state, or you can say being at a particular state and depending upon, you can say depending upon the input symbol automata transit to the next state, or you can say next new state. See, the behavior of your finite automata is like this. At any point of time, okay, during processing a state with finite automata, you will be at a particular state, and being at that state, by having a input symbol, you do the transition to a next state. This is only the way of behavioral way of finite automata. What here you were looking for, you were at a particular state, and by having the input, you are moving to the new state. So how mathematically we can write it? Delta, okay, what I can say? Q or Cartesian product sigma implies Q. Being at a particular state and having a input symbol, you are doing a transition to the particular state. Okay, and the PDA is exactly the way the working of PDA we can see here. Since the PDA is having a additional arrangement in addition to the arrangement the finite automata is having, what are the components of finite automata? Machine model में क्या क्या component थे? What are the components of finite automata machine model? Tape, okay, there was a tape, and that tape was divided into cell, and that tape we were using to store the input stream. And क्या था? This is a tape. This is what? Finite state control. The machine model for finite automata is this one. Last lecture में बताया था हमने, डिस्कस किया. Finite state control, there is a tape. सारे आपके ट्रांजिशन फंक्शन यहाँ पे रहेंगे. Okay, so there is a input string to be stored onto the tape. So how it works? Initially, the finite state control will be at a particular state, initial state, and some inputs will be there written onto the tape. So how this is the initial configuration. So there is a initial configuration for finite state, this particular machine. So initially this finite state control will be in Q0 state, initial state, and its heads will be pointed to or reading to the first symbol of your state. Now you can start this machine. So depending upon the initial state and current input symbol, and it decides to what state it should go. डेल्टा फंक्शन वही बोल रहे हैं ना आपको. डेल्टा फंक्शन क्या कहते हैं? एक पर्टिकुलर स्टेट में रहते हुए और एक इनपुट एक पर्टिकुलर सिंबल के साथ कहां पे ट्रांजिट कर सकते हैं. ओके, सो इन if suppose q0 for a I am moving to q1, what it clearly means that being at q0 by having a input symbol a at q0 state, where do you are able to move q1 state. So that exactly. So this is the machine model I am talking about. Initially, see, it is said that to start with a finite automata you should start with the initial state. So initially your machine model, finite state machine model also remain in the q0 state, and depending upon the function you are having for a particular finite automata, this finite state control will jump to the one state to another state during processing the input signal. Last lecture में हमने a b b का कुछ लिया था ना. So our finite automata was like this. तो इसके फंक्शन क्या हो गए? What are the transition function I can have by looking at this finite automata? Delta q0 a q1, delta q1 b q1 itself implies q1. So this is what here I written. The working of finite automata is like this. Being at a particular state and depending upon the input symbol, automata transit to the next new state. Okay? But how PDA works? Being in a particular state, and depending upon the current symbol. Here what I have written is input means what? Here you can consider as a current symbol. In another way, being at a particular state and depending upon the current symbol, and most importantly, see here is the important point about PDA. The current symbol and top of stack symbol. PDA transit to the next state, or you can say next new state, and again one importantly, it not only go to the new state, it also do some action. Okay, and do the action over stack please remember this thing. Once you understand what PDA is, your concept becomes very simple. Come in. Like what exactly it do? It write, or you can say push, or what kind of action it do? It can do push or it can do pop. So mathematically, as the way it will be written mathematically it can be written as, see, if you look at what the inputs are, state and current symbol and top of the stack. Depending upon the state, current symbol and top of the stack, what it does, PDA transit to the next state and do most importantly the action. And actions are push or pop. So that we can write in mathematical way. Q being at a particular state and being a for a particular current input symbol and for a stack symbol or top of the stack, depending upon the input symbol, depending upon the top of the stack, your PDA transit to the next state Q, and it also do the action over the stack, and that action we represent like this. It may be push or pop. This state means, see, what are the inputs? State Q, current symbol sigma. What is sigma? Sigma क्या होता है? Set of terminals. So symbols are terminals. Current symbol sigma. Top of the stack. Here I have taken this. What this symbol is? Gamma. नहीं gamma. वो हम ऐसा लिखते हैं ना? That is written this way. ये capital gamma है सर. This is capital gamma. Okay. So Q, sigma, and this is the top of the symbol of top of the stack, and it implies a new state and action over the stack like push and pop. Get it? Fine. Now I will teach you how to design a PDA. Okay? In the last lecture we had designed a PDA for A raised to n, B raised to n. कैसे किया था हमने? कैसे किया था? सारे A's A पुश किया था और B को जैसे B इंट्रोड्यूस हो गए हम A से रिप्लेस किया, एक B आ गया तो एक A पॉप किया, नेक्स्ट B को नेक्स्ट A पॉप किया, इस तरीके से. ठीक है? नाउ डिजाइन ए PDA. The question is, this is the most important question you will get in examination for 8 marks for sure. WCWT. What is this? T means transpose. Okay, it is a palindrome string. WCWT means palindrome. For example, my string is A B A C A B A. Or you can say B. So how should I have? B B A. W transpose of W means reverse string. Or you can say like this, you write like this. Reverse, R for reverse. Okay? So A B B C. C is what? A center symbol. B B A. This is, I can say, as a palindrome, odd length palindrome. So how question is to design a PDA for this. First of all, to start with designing any PDA, first of all you should have a visualization for your machine. PDA मशीन हमने इमेजिन किया है ना, टेप है. PDA का मशीन कैसा है? टेप, finite state control, additionally stack. This is a PDA. Got it? can connect this with this, or in this case you can change this name as a finite store control. This much machinery is controlling the store. Okay, and that control is not an unlimited control, it is a finite control. So that is why this is a control really controlling the storage. So that is why the name finite store control. So that is connected to here. Again, this finite control is also controlling the head to read the symbol from the tail. So इतना आपके सामने इमेज होना जरूरी है, ठीक है? So by having the string like this, in our case, the string in our case is like what? ABB, A B C B B A. This is my string stored onto the tape. My length of my tape is infinite. So how do you go for? Logic is very simple, huh? Just go on pushing. Start with. शुरू से बोलिए आप.
Push A first.
Okay.
Then B.
Okay.
And again B.
हाँ.
And when we push C, when C will be encountered, we will do pop B.
What you will do with C? Do you push it?
No.
You don't do anything with C.
C जेव्हा येणार त्यावेळेस pop करायचं.
हाँ म्हणजे C आल्यानंतर काय तुम्हाला कळणार आहे की पुढची जे स्ट्रिंग आहेत ना ते याचा रिफ्लेक्ट असणार आहे असं तुम्ही अज्यूम करताय, बरोबर आहे? सो व्हॉट यू आर डूइंग विथ C? C symbol, when C will be you are processing, when you are processing C, what you will do with the C? Do you push it or pop it? You don't do anything. Okay? Means it is not necessary that you need to push or pop. Okay? You may also do the action. Don't do anything. Huh? There must be one more action. That we will see. So when you encounter with C, you don't want to do anything. Only you are reminding, you are understanding that yes, once I encountered C means what? Next, what I need to do? I need to, yes, what you do? You want to pop. Okay? So how do you pop? You cannot pop directly. But what condition you should have to pop? Current symbol and top of the stack should be same. Do you understand? Right? Currently you have pushed A on the stack. B is on the stack. B is on the stack. So what is the top of the stack now? B. You have not done anything with C. So what is the top of the stack? B is there. So next input symbol is B. Current symbol you are under processing is B. Top of the stack is B. So what do you decide to at this moment? You pop. I pop this B. So what do you do with my head is here. Okay? My top of the stack is B. My head is here. What do you do? Since you are having current symbol and top of the stack are both same, you are popping that. Next, my input symbol is current symbol is A, and my top of the stack is A. So what do you do? There is a match. You decide to pop it. Okay? Fine. हाँ इसके बाद क्या करेंगे? हाँ बढ़िया. Thank you. Very good. What you do is okay, fine. So what you declare? अभी यहाँ पे सारे पॉप हो गए. What you are having? How do you declare that this input string is odd length palindrome? If the stack is empty, then you declare. You will look that the stack is empty. How do you understand stack is empty or not? There is a marker. You should see the top of the stack is Z0 or Z. Stand up. बैग लेके बाहर चले जाओ. बैग लेके बाहर चले जाओ. Do it fast. हाँ? क्या कर रहे हो? Now we will go for the next language. A raised to n, B raised to m, C raised to n. My language is A raised to n, B raised to m, C raised to n. Here input symbols are A, B, C. What kind of sentences I am having in this language? Equal number of A's and equal number of C's. In between, any number of that any is not specific. We should define it. Huh? I should say n is greater than or equal to 1 and m is also, or I can say greater than or equal to 1. This is my language. A and C, n is at least 1, m is also at least 1. So this is the machine and this is the string. How do you process? And if your string is in this form, then your machine should accept it. And if the string is not belonging to this language, such string should not accepted by. Most importantly, if your string is not belongs to this language, then such string should not be accepted by this machine. Such PDA you should define. यहाँ पे लॉजिक क्या बताइए? Or you can consider it as 0 to make it the problem simple. आता काय करायला पाहिजे सांगा? हो बरोबर आहे. मग m साठी काय करतात? b साठी 0. बरोबर आहे. मग असेल तर B's असेल तर if B's will be present, for example my string is like this. My string is A, B, B, C, C, C. How do you process this string? हाँ. Pop करा. Okay. Again, it is simple. It's just like the logics are very simple, huh? So do push, don't do anything, do pop. Okay. So these are the kind of the logic we are able to develop by looking at the problem. But how to represent the solution, this logic onto the paper? Okay, this is a simple logic, and by this logic we are able to design a PDA. But how to put my PDA onto the paper? That is a question. Okay. So in that case, these delta functions helps you. Okay. What is my for the language? For the language L, I don't write G here because the grammar is not here. I simply write L because I want to indicate it is a language. Girls. So my language is W C W R. W is any string. Over A and B. This is my language. So designing a PDA for this language, it clearly means that designing a transition function. This delta functions for this. Okay? Designing PDA means what? Working out the transition functions. What are the transition function for this language? Start with the initial state of your PDA. PDA का initial state क्या है? Your PDA is initially your stack of your PDA is empty. It means that Z0 is stored, okay, at the bottom of the stack. This is the assumption you have to do. Your string is stored onto the tape. This assumption you have to do. And your pointer is pointed to the first symbol of your string. Okay? This is your initial configuration. So by assuming that, you should go for designing a transition function. First transition function I am going to design. What would be my first initial configuration? I will be assume that you are in the state Q0 and you say that my Q0 is the initial state. Okay? You are working with this W, this kind of string. You may start, your first symbol of your string may be A or B. Okay? A or B. W is of A or B. So you should consider, first of all you consider your input string is A and top of the stack is what? Z0. See, I am following this transition function. By having this, what do you want to do? What do you want to do with the first symbol you just read from the tape? You want to push. So how do I write it? State. Where do you go? I assume I am remaining in the same state and I want to push. How do you push? AZ0. Why AZ0? Base over the base of your bucket or bottom of your top of the stack we are putting A. This इस तरह से understand करना है. So this is top of the stack and one more symbol here we added. It means what? Added something to the stack means you pushed that particular symbol onto the stack. Do you remember this? Okay, fine. Next, what you are doing with if you are encountered with B at the very start, what you will do? At the very start you will get B. May get B. That also you want to push. B Z0. Then in this way, what you will do? You started with Q0 and you are right now in Q0 state, and by having A's and B's, you just pushed onto the stack and you are right now in Q0 state. आप Q0 state में हैं, Q1 state में हैं. ये स्टेट प्रोसेस करते वक्त आप C तक पहुंचने तक आप किस स्टेट में रहेंगे? स्टेट में रह गया, आपने स्टेट चेंज नहीं किया। हाँ हाँ कहाँ पे ये आएगा? Q0B नहीं, ये जो इनिशियल क्या हुआ, आपका स्टैक एम्प्टी है और फर्स्ट सिंबल B है, तब की बात है। इसके बाद क्या होने वाला है, नेक्स्ट B और नेक्स्ट A जो आएंगे तो उसके लिए वेरी गुड, ये फर्स्ट सिंबल पुश हुआ, ये दोनों ट्रांजिशन फंक्शन से। नेक्स्ट Q0 A and top of the stack is A, what to do? Q0 A you have pushed. It may be possible that top of the stack is B. In that case, Q0 A B Q0 A B. Other way, Q0 at the top there is a but you are reading B. Okay, at that time what you do, you push B onto the stack and top of the stack is B and current input symbol is B and you are in the state Q0, you again want to push it onto the stack. समझ कहाँ नहीं समझ में आया, पूछो मुझे। ठीक है, which transition function you have not understood? Q0 AB त्याचे टॉप वर B आहे आणि करंट सिम्बॉल नाही अजून C पर्यंत पोहोचलेलं नाही आहे, C च्या आधीच अजून प्रोसेस करतोय। फर्स्ट B इथे बघा जेव्हा मी माझ्याकडे इनपुट सिम्बॉल A आहे त्यावेळी स्टॅक वर A अथवा B असू शकतो की नाही, त्यावेळी काय करायचं, त्या दोन्ही in these two situation what I decided to push that A. When I am having a B input symbol, at that time my stack may have A or B. At that time, what I decided to push onto the stack. Okay. Now see. Are you convinced? Yes, I will show you. My strings are A B B C B B A. Okay, my stack, top of the stack is empty and at the top I can see Z0 is there. So what I do, I am in the Q0 state. I am in Q0 state. Current symbol is A and top of the stack is Z0. What I do, I push that symbol onto the stack. So A is here. I pushed. Next, B symbol, current state is Q0, top of the stack is A. What I do? Q0 B A. Where can Q0 B A? Here. Q0 B A. What do? You push that B onto the stack. Now again you are in the Q0 state and current symbol is what? B. So Q0 B B. What do you do? B B means that B again you have pushed onto the stack. Here I am coming to C. Is it okay now? So I am coming to C. What to do? Delta. See, basically here I decided to not to do anything, but how to not to do that I am going to show you. Right now I am in Q0. C is there, and I will have A or B at the top of the stack. Is it okay? I may see A or B onto the top of the stack. What do you do? What should I do? I encounter C. There is A over the top of the stack. I decided to not to do anything. Means I should not show null. Null means it erases the top of the stack. Okay. So I write like this: Q0 A itself. Q0 A. It clearly means that top of the stack is A and keep it as it is. Similarly, for B also, I write like this. Now once I encountered with C, next coming symbol I believe that the string should be a reverse one, and I decided to pop. Okay? How do I pop? Delta अभी हम क्या करते हैं? What we will do? Since here I encountered with C, I am from one place to I am really moving to the another place. Initially I was pushing, and right now I am going towards the string where I needed to pop. There are two different environment situations, so there are two different states I can say. Okay, so when you encounter with C being at Q0, go to the state Q1. And here also you go to the state Q1. So here you need to realize from state means what? Being at a particular state, I am doing a same kind of job, same kind of task. Being at Q0, I was only pushing the symbol over the stack. But after encountering C, I am going to pop. Means I am doing some other kind of activity. That is why I changed the state from Q0 to Q1. So Q1, being at Q1 state, I am having a and top of the stack is what? It always should be A. Huh? Then what you are doing? Q1, you are popping that. So it never be the situation. This kind of situation, it should not occur like A, B. ऐसा situation कभी आएगा नहीं. You are in Q1 state. Top of the current input symbol is A. Top of the stack is B. ऐसा कभी होगा नहीं. अगर हुआ, it clearly means that your string is input string is not a palindrome. Okay? So this kind of situation won't occur. Only another case you can find that QBB, Q1 null, and delta. So by having these two transition functions, you are able to pop all A's and B's. Is it okay? Is it understood? Are you able to pop or not? Miss? Yes. So after popping A's and B's, what you will do? You will be remain. Your string will be get empty. There will not be any symbol left with you, and your top of the stack will be Z0. Then you will be going to the state QF and Z0. And this is the final state. This is our Q0 initial state. So during processing your string with this PDA, you came across to the QF state. It clearly means that your string processed is of kind palindrome. Okay? Otherwise, by taking any non-palindrome string, it is impossible to reach up to this QF state. Is it correct? Do you agree? Take any non-palindrome string, and in that case, it is not possible to reach to the QF state. Okay? So this is all about a delta functions. Okay? For your PDA. Now write a PDA. Yes, I am finishing. PDA. My PDA is how much tuple? 6 tuple. 6 tuple, 7 tuple. 7 tuple है. Q0. मुझे बताओ, मैं भूल रहा हूँ. टाइम किसी पास नोट्स? हमारे फाइनल ऑटोमेटा बताइए क्या था? फाइनल ऑटोमेटा 5 टुपल. क्या क्या बताइए? उसका ऑर्डर बताइए मुझे. Q0 सिग्मा. Q0 सिग्मा डेल्टा. स्टार्टिंग क्या है? कैपिटल Q, सेट ऑफ स्टेट्स. डेल्टा Q0 F. And this is about finite automata. Your PDA is exactly Q sigma स्टैक सिंबल. ये जो स्टैक पे हम सिंबल पुश कर रहे हैं ना, वो सिंबल. इस एग्जांपल में स्टैक सिंबल और इनपुट सिंबल दोनों सिमिलर थे. आप कैसे? You can take any other symbol like A and B. I consider A and B. See, A and B I am pushing onto the stack. My stack symbol Z0 is again stack symbol. A and B is again stack symbol. So A and B I am considered as same as my input symbol A and B. It is not a compulsory to take the same symbol what the input symbol you consider for tape symbol or sorry stack symbol. Okay? So you may consider X and Y for stack symbol. मान लीजिए जैसे if I am having A, my input symbol Z0 is my top of the stack. I can go for pushing X onto the stack. A के लिए X, B के लिए Y. ठीक है ना? So in this way I can have a separate set of stack symbols. Okay? So that is for sigma. Sorry, it is what? Gamma. It is gamma. Capital gamma. Gamma क्या gamma?
Gamma.
Okay, fine. It is Q sigma gamma delta Q0 Z0 and final step. Where Q is what Q is? Is this order is correct? You check it out the order, but these are the 7 tuples. Q is what? Non-empty set of states. Sigma is non-empty set of input symbol. this is non-empty set of stack symbol. Delta is the transition function. This is the delta we defined for a language what? That L. Q0 is what? Q0 is the initial state in our case. Z0 is what? It is Z0 is a set of it is not set na? Z0 is the marker symbol. Okay? F is what? Final state, and in our case design PDA, here QF is my final state. This way, after designing this way, you have to write all this. My Q is what? Q is what? Q0, Q1, QF. Sigma is what? A, B, C. This gamma is what? A, B, Z0. Delta is what? That is a delta. And Q0 is what? Q0 is Q0. Z0 is Z0. And F is what? QF. Q0 is Q0. Z0 is Z0. So Z0, see, this Z0 is symbol in the definition. But Z0, this Z0 you have considered a symbol to put as a marker onto the stack. That is why you have to write Z0 is equal to Z0. You can put the stack symbol, the bottom of the stack or marker of the stack by any symbol, X will label. But what? By what name we define in our PDA? By Z0. Z0 ये हमारा हाँ जी, ठीक है? This is the definition, and this is called as a design of a PDA.